Hi, this is our final project for ME100. Our team name is Solar Security, and I am Mitchell Braun.
And I'm Alexander Castillo. So this is our outline of what we're going to be doing today. First, we're going to cover the application need for our product. Then we'll talk about how it goes about completing the requirements for sensing, actuation, computing, and communication. We'll dive into our initial design, and then we'll cover our final outcome and design. Then we'll explain the circuit and go into the code, and finally finish off with our final results in the conclusion.
Right, so we're first going to start off with the application need, which revolves around security. As we all know, it's a dangerous world out there, and profit shouldn't come before people. With this affordable solution, we can retrofit existing systems to serve more than one purpose and protect those that matter most.
So for sensing, in a way, this goes about with two different solutions. So first, we use the built-in motion sensor in the garden solar light to detect when someone's passing by. That causes it to then flash its own light, which shines on our solar cell. And we use the ME219 to detect voltage. With that, then we can complete and go into the actuation phase.
Right, so for the actuation, like Alex said, once we get that light detection, it transmits data to, we get data from a solar cell, which then goes to the speaker, which kind of makes the detection. Furthermore, we have an MQTT protocol, which sends data to Adafruit. From there, we have an IFTTT sensing that, and that sends an email to the user alerting them that someone has walked by.
So for computing, we look at 1 second intervals. The light's on for about 15 seconds, but if we want a quick response and we want it as fast to the user as possible, without overwhelming the ESP32, we thought a 1 second interval is reasonable. And depending on how we change the potentiometer, we found that like the voltage at what we had it set at around 0.05 is enough to then trigger it without it causing to be triggered right away by some outside sources like light that somehow seeps into the box.
Mm-hmm. Right, so for the communication, like I kind of said with the activation, we MQTT sends a message to our Adafruit profile, and then IFTTT grabs that message and then kind of just sends an email to the user alerting them that someone has walked by. Right, so we're going to now do our video demonstration, which is on YouTube with the link provided. So we can kind of commentate stating that this is going to be me sleeping on the couch, kind of having the security system set up.
Here we can see the intruder or me coming in to rob our victim. He's sneaking through the streets. And here he approaches the door.
We can then see that he's looking through the window, checking if there's anybody there, maybe scoping out the house to see what he's going to steal. Of course, he's going to open the door, making sure that he's going to take off his shoes because he's a clean burglar. Here we can see our demonstration actually work. He's going to walk by. You can see the light flashes, which sending a noise and also an email to the user, which he gets, looking at the intruder and then scaring him off. Here we can see that he's grabbing his shoes, opening the door, and then bolting. And then just our very appreciative consumer that he has his product and that has saved his life.
All right, so this was like our initial sketch. We wanted to use our device to improve an existing product and thought it would be interesting to take something cheap like one of these garden lights, which will cost around like 12 bucks, and seeing how we can improve it. And we thought by adding this security system, since it detects motion, would be like a natural fit. And our initial idea, again, was just using the solar cell somehow to detect when the light would turn on, and then eventually coming up with some way for the user to be notified. So this is our packaging. Again, this is just a rough prototype. This wouldn't be how our packaging actually worked in like a final product. We just wanted to create a dark environment for the ESP32 and the solar cell to be in, so it wouldn't be set off by just the ambient light. And if we were going to something like a final product, we would find better packaging, probably package it behind the light or in some other way that's more convenient for a user. And also, so the users can place it outside, we thought of weather resistant packaging that would protect it from rain and the elements. This is a breakdown of our circuit diagram. So we used the same circuit from like lab 2, but we added onto it. So that circuit would like tell us like the voltage and the current flowing through. And then we used what we had from the speaker lab to then create a response with code, again, we'll show later, that alerts the user through sound. And also we used the lab where we covered IFTTT to then send a message to alert the user. But again, that's more visual in the code. These are just some pictures of just our circuit, what it looks like outside of like the diagram, what the actual physical product is.
All right, so now we're going to jump to the code. On the left, we can see that we're grabbing everything from the libraries. We're initializing the INA 219. And on the bottom half of the left, we are declaring our variables for the sound. On the right, we're just declaring the sound array. Again, we just wanted to create a basic sound so that we could alert the user. So we grabbed it from lab 6. On the left, we are initializing the MQTT protocol. We are setting up the Wi-Fi, making sure that it's working, putting in our strings for Adafruit profile, creating the MQTT client. And on the right is more of the intruder detection code, where we are making sure that the message is being sent, initializing our sound, creating our method for the sound to loop. And then at the bottom right, we can see that we're just having a while true. We're just going to run forever, just making sure that if it senses a voltage above 0.05, it will first print the voltage, run through the sound, then publish to the MQTT, which goes through the Adafruit. And on the side, which is not shown, we have an IFTTT set up, which sends an email to the user. Before we get to the inclusion, I will show the email that we got from the IFTTT. Right, so right here, we can see that at the time where we took place, we got our intruder alert messages, which was subscribed to me, and we got quite a few of those. So now we're at the conclusion. Just to summarize, our project creates a new way of detection that kind of branches off the garden light, which provides security and safety to our consumer. And is there any questions?